Hi, welcome to my channel. In the previous video, we discussed about the definition of decision tree, definition of decision tree, and also we discussed about the types of decision tree classifier algorithms like ID3 algorithm, C4.5 algorithm, and CART algorithm. And also we discussed about the how to train and how to visualization of the decision tree with the help of different algorithms like CART algorithm and ID3 algorithm. And also we are going to estimate the class probabilities, estimation of class probabilities, and also we predict the corresponding class labels for the given data set. Okay, now we are going to discuss about the regression in this class. So here first of all the decision tree is we are going to apply for the classification as well as regression purpose. Okay, already you know what the difference between the classification and the regression. Okay, now in the classification we are having the three different types of algorithms are there. One is a ID3 algorithm, C4.5 algorithm, and CART algorithm. So based on this information we are going to construct the decision tree, and the tree contains, for example, this is the root node and intermediate nodes are there. This is suppose leaf node, and this is one intermediate node, and leaf nodes are there. So the root node and intermediate node we are going to identify some features or conditions on the features, so that we can divide the data into two parts, that is yes part or no part. If the condition true, okay, we are going to leaf node or other intermediate nodes. Okay, based on these conditions, repetition of these conditions, we are reaching the leaf nodes. The leaf node contains corresponding class labels. Okay, corresponding class labels. So the leaf nodes provide the class label for the given information. Okay, for example, here if we are giving the input like for example our data set is equal to iris flower data set. In this iris flower data set we are having the four features like sepal length, sepal width, petal length, and petal width. Okay, and the corresponding class labels are setosa, versicolor, and virginica. Like that we are having the three class labels are there. Suppose we are giving the based on this information our model is going to train on the only two important features like petal length and petal width. Okay, based on this information, suppose we are giving the new information to our model, our decision tree model. Okay, for example 5 and 1.5. Okay, so based on this information you have to find out the corresponding class label, whether it becomes setosa or versicolor or virginica. Like that we are going to find out the corresponding thing. So this type of problem is called as a classification problem. So for the given information, given input features, you have to provide the corresponding class label. This is called as a classification problem. So here we are going to estimate the corresponding class level by the help of a decision tree. This decision tree is going to be connected with the help of ID3 algorithm, C4.5 or CART algorithm. That is already you know. In the regression also, okay, we are going to construct the decision tree, but here the main thing is we are going to use the concept of mean squared error. Okay, mean squared error, squared error. Okay, there are different types of error points are there. Squared error. Okay, and also we are having the some concepts of here the output of this one is going to be we are giving the input values. We are giving the input values. Okay, like suppose any value we are giving the two input values like A and B. We are giving the input values. We are going to predict the corresponding values only. Okay, value in the form of a real number values. Okay, so suppose it is a 0.5 like that we are going to get the 1.6 like that we are going to get the values, so that it can be estimated with the help of regression. Okay, this is also done with the help of decision tree only. So simply that is the difference between the classification and regression. Now we are going to see the in detail about the regression concept of the decision tree. Now the decision tree are also capable of performing the regression tasks. So let us build a regression tree using the Scikit-learn's decision tree regression. Suppose you want to consider the decision tree classifier, then we are going to use the concept of a decision tree classifier. Okay, but we are going, our aim is we have to construct the decision tree regression. So we are going to use the concept of decision tree regression class. Training, so based on this decision tree regression class, we are training it on the nice squared data set with the max depth equal to 2. So here our data set is a nice quadratic data set with max depth equal to 2. So from the Scikit-learn tree dot, we are going to importing our model is called as a decision tree regression. So tree underscore regression, that is a model name. Okay, that is our variable equal to decision tree regression, and we are going to provide the hyperparameter equal to max underscore depth equal to 2. We are fixing the size of the tree equal to up to 2 levels. Okay, max underscore depth equal to 2. Then tree underscore regression dot fit further providing the corresponding features and corresponding values. Okay, so that is called as a training the model. So now we have see the different types of parameters here. Okay, in the decision tree regression. Now class Sklearn dot tree dot decision tree regression, the criterion equal to squared error. So suppose if it is a decision tree classifier, here the criterion equal to Gini value or entropy value or shape. Okay, like that we are having different types of entropy things are there. But this is a regression. Okay, now the criterion equal to change as a squared error. The splitter equal to best, max depth equal to none, min underscore samples underscore split equal to 2, min underscore samples underscore leaf equal to 1, min underscore weight underscore fraction underscore leaf equal to 0.0, max underscore features equal to none, random state equal to none, max underscore leaf underscore nodes equal to none, min underscore impurity underscore decreases equal to 0.0, CCP underscore alpha equal to 0.0, and monotonic underscore CST equal to none. Like that we are having the different types of hyperparameters are there. So here the default criterion equal to squared error, and also we are going to set the maximum depth of the tree equal to 2. Okay, based on these two parameters we are going to construct the decision tree regression. Okay, so here we are having the different types of hyperparameters things are there. Okay, random state, random nice data set. This is a nice quadratic data set. Okay, now here the total number of elements in the sample is equal to 200. Okay, and the corresponding value equal to 0.354. The previous we are having the class labels, we are having the here values. Suppose if it is a decision tree classifier, we are having the class labels here. This is a model called related to regression. That's why we are having the value equal to 0.354. And also see the difference here. We are having the mean squared error. Okay, mean squared error. If it is a decision tree classifier, we are having the Gini value or entropy value here. But we are having the here MSC mean squared error equal to 0.9098. Like that we are going to have the tree. Okay, so if the x1 is less than or equal to 0.197, okay, then if it is true, okay, then we are going to check the other condition here, and otherwise it is a false, then we are going to check the other condition here. Like that we are going to connect the decision tree. At the last we are having the values like samples equal to 10 and mean square equal to 0.018 and corresponding value equal to 0.854 and mean square equal to 0.013 and number of samples equal to 24, value equal to 0.552, and here the 0.015 is the mean square error, and the number of samples equal to 110, and the value equal to 0.111, and the mean square equal to 0.036, samples equal to 46, and value equal to 0.615. Like that we are going to have the predict the corresponding values. Now this tree looks very similar to the classification tree. The main difference is that instead of predicting the class label in each node, it predicts the value. That is the very difference between the classification and regression. Now, for example, suppose you want to make a prediction for the new instant x1 equal to 0.6, x1 equal to 0.6. So at that time, we are going to traverse the tree starting at the root node and eventually reach the leaf node that predict the value 0.11. Okay, so that means our aim is the x1 equal to x1 equal to 0.6, x1 equal to 0.6. So here the x1 equal to less than equal to 0.197. Okay, that is on the right is true. So that's why we're going to, that is the x1 equal to 0.6. So that is false. So here we are checking the condition. Our value equal to 0.6. The 0.6 is less than the x1. Okay, that's why we're going to left of the depth 2. Okay, depth 2. Right node of the, okay, this is the level 0, level 1, level 2. Okay, and the level 1, okay, the level 1, we're having the two nodes are there. The right node of the, okay, right node of the level 1, okay, that becomes the, check the condition here, and we are going, the condition is true here. We have the, then we're going to find the value equal to mean square equal to 0.15, and the corresponding samples are equal to 110, and the value equal to 0.11. Okay, like that we're going to find out the corresponding value. This prediction is very average target value of the 110 training instances associated with the leaf node, and it results in the mean squared error equal to 0.015 over these 110 instances. So here this is the prediction of the represented in the form of two diagrams are there. Here we are having the max depth equal to 2, and this is about the max depth equal to 3. So here we are having the range of values between 0, x1 equal to x1 between the 0.0 to 1.0, and the corresponding y value predicted between the minus 0.2 and the corresponding 1.0. Okay, these are the random data set. So for that we are going to max depth of the tree equal to 2. Okay, so here the data between the minus 0.2 to, okay, 0.1, 0.8. Okay, that is one data set points are there. Here all these points, for this all these points we are going to predict the corresponding value equal to corresponding value is 0.2 some 1 like that. Okay, 0.115 like that. Okay, so whatever the values are raised between the 0.2 to 0.7 here, for example 0.79. okay, whatever the values are there, whatever the splitting of the data points are there, we are going to predict the corresponding value as a 0.115. okay, and also we are going to split the data into two parts here once again. Okay, in the left node. Okay, at the depth 1. So suppose the values are between the 0.1 to 0.1.2, 0.2. okay, or the range of data points are here. Okay, for all these points the mean square are equal to, okay, you are finding the regression point equal to at 0.255 something. Okay, so what are the data points are there? We are going to predict the corresponding value as a 0.55, and also the data between the 0.0 to 0.1. okay, these are the range of values are there. For all these range of values we are finding the corresponding value as a 0.86 like that. Okay, so like that we are going to predict the corresponding value, not the class label. So this is about the regression. Okay, like that this is the changes based on the max depth equal to max depth equal 3, so that we can get the better look of the value. Now if we set the max depth equal to 3, we get the prediction represented on the right hand side. Notice that how the predicted value for each region is always the average target value of the instances in that region. That is the major difference here. So here each region is always the average targeted value of the instances in that region. Suppose here the values between the 0.2, 0.278, for example, whatever the data points are there here, all these blue points are called as data points. Now the data for all these data points are going to predict the value as in the form of a average target value. Okay, what are taking the average of all these values, we are going to predict the corresponding value as 0.11 like that. Okay, the algorithm split the each region in a way that makes the most training instances as close as possible to that predicted values. So the CART algorithm works mostly as the same way as earlier. Okay, except that instead of trying to split the training set in a way that minimize the impurity, it is now to tries to split the training set in a way that minimizes the mean squared error. So the difference is we are going to minimize the impurity in the classification, minimize the impurity in the classification, but whereas the regression we are going to minimize the mean squared error. Okay, so here the equation 4, that is our algorithm shows that the cost function that algorithm tries to minimize the corresponding regression value. The cost function for the regression equal to j of k comma tk equal to m left by m into mnc mean square error of left subnode plus mean square m right by m into msc right. That means left subtree by total number of elements in the left subtree by total number of elements in the entire tree into mean squared error of left subtree plus right subtree total number of elements in the right subtree by total number of elements in the entire tree into mean squared error of right subtree. Okay, where MSC mean square error node equal to sigma I belongs to node, each and every element belonging to corresponding node into of y cap of node minus y of I whole square, that is the predicted value minus actual value whole square, that gives the mean squared error. So y cap node equal to 1 by m node into sigma of I node of yi. Okay, that is gives the cost function of the regression. Now, just like for the classification task, okay, here the decision tree are prone to overfitting when they are dealing with the regression task without any regularization, but that is default hyperparameters. We get the predictions on the left side. Okay, so like that. So suppose here we are not we don't have any restrictions on the our hyperparameters in the decision tree regression. Our model is a decision tree regression. Okay, here there are two things are there. One is without any hyperparameter changes and with hyperparameter changes. That means without hyperparameter changes, we are going to get the every point becoming one separate value. Okay, this is called as a overfitting. So in the left hand side, this is called as a overfitting. Okay, now this is avoided by changing by regulation of hyperparameters, by simply changing the values of min underscore samples underscore leaf equal to 10. So automatically the corresponding data is going to be minimized. That means we are going to be regularize our parameters so that it avoids the concept of overfitting. So the model works very well. Okay, by changing the hyperparameters. Like that, we are going to construct the decision tree for the regression also. So these predictions are obviously overfitting the training set very badly. Just setting the minimum underscore samples underscore leaf equal to 10, the results in a much more reasonable model. So that is represented in the right side of the figure. Okay, so here we are setting the min underscore samples underscore leaf equal to 10. So these are the better results compared to this one. Okay, so like that we are going to overcome the overfitting. So like that we will construct the decision tree for the regression also. Okay, thank you for watching our video. If you like the video, please subscribe to my channel. Thank you.